And welcome back to another LeetCode video. We are looking at a LeetCode easy problem, which we're going to use to practice coding interviews with. So this one is LeetCode 3461, and we should check if digits are equal in string after operations. Well, let's find out what those operations are by understanding the problem first. So we're given a string S consisting of digits. Perform the following operations repeatedly until the string has exactly 2 digits. For each pair of consecutive digits in S, starting from the first digit, calculate a new digit as the sum of the 2 digits modulo 10. Replace S with the sequence of the newly calculated digits, maintaining the order in which they are computed. Return true if the final 2 digits S are the same, otherwise return false. So this means we probably have to do like a simulation where we actually perform all of these operations until we have only 2 digits left. I don't see right now if there's a different or closed form approach. Probably not, what I'm guessing. So the next step would be, well, let's understand the constraints. Okay, we're given a string S, and that consists of digits. Well, can S be empty? Can it be none? Can it have leading zeros? Should we care? What does S look like? That's what we want to know. And LeetCode tells us that, well, it consists only of digits, and it has at least a length of 3, which is very good to know. So we can always perform these operations at least one time to end up with a string that has 2 digits or more. Right, so let's look at an example to understand the mechanics of the problem. And that part is usually to find out, if you can see a solution. So we should really pay attention and go through the examples in an interview if you can. And you can ask the interviewer for example inputs, or you can make up your own, try to come up with some edge case, etc. But here we're already giving them. So here the input string is 3902. And if we perform these operations, so let's try to do that. So we take 2 consecutive digits, replace them by their sum modulo 10. So 3 and 9 would be 12, modulo 10 would be 2. So that means we replace 39 with 2. And then we have O2, which is also ends up to be 2. So we have 2 2s. All right. Oh no, it's they're actually overlapping. So we can't just compute the sum of 39 and O2. We also have to compute the 2-digit sum of 9 and 0. And here we see that. So we first combine the sum of the first 2 digits, that's 0 modulo 10. The second is 9 and 0, that's 9 modulo 10. Then I have a 2 modulo 10. So now we perform the operation again because we have 3 digits. So 2 plus 9 is 11. Modulo 10, that's 1. 9 plus 2, that's the same. So we end up with a string that has 1, 1, and the output therefore should be true. And here we have an example where we return false. I don't think we need to go through it. I think we've understood how to solve the problem. So we need to go through the string and combine every 2 consecutive digits together to form a new string. Now, I would suggest we use an array in Python for that. Because creating a new string, appending a letter to a string is often always an O of n operation, so that's going to be costly. So what we want to do is just use a list where we can just append the new digits. Cool, and we do so until the list has only 2 entries. And I think we could solve this problem then in what would be the time? Well, if we have a string of n digits, right? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Well, if we perform all these operations, we will end up with a string that has 1 digit less, right? And that will continue until we come up with a string that only has 2 digits. So this looks like it's going to be iterating over all of the digits, but doing this n times to reduce them to 2. So I think we'll have an O of n squared solution, n times n time, and we only always need to keep track of maybe the current digits that we're working with. So that's going to be O of n space, where n is essentially the length of the string S. So yeah, now at this point, I think I have come up with a solution with an algorithm, including its runtime and space complexity. If you can do that from the get-go, that's going to be very nice. If you can't do it, don't sweat it. You can always do your complexity analysis after writing the code. So now I would ask the interviewer, can I actually write the code? And so, yeah, please. That sounds awesome, sir. Please go ahead. And yeah, so let's just implement that. And the way I would implement that is I would have a little helper function that can compute me that can go through all of the digits and compute me the new, set of digits. So I'll have a little helper function for that, maybe. Little helper function. And I want to pass it an array, right? I said I want to use an array. So what I need to do is, of course, I need to convert everything into integers and an array to be able to do math with it. So 4-digit in S. So we're actually iterating over all of the characters in the string. We call the character digit, and then we transform it to an integer value between 0 and 9, right? And then we would call our little helper function while our length of error array is larger than 2. We're going to call our helper function, and I'm going to implement it in such a way that it has side effects so that it doesn't return anything, but it will modify our little array here. And then finally, what we have to do is, we have to check whether the index at array position 0 is the same at position 1. And we're guaranteed that we will always have at least 2 elements in it, because in the beginning we're guaranteed to have more than 2 elements in it, right? Because length of S is 3 or larger. So with this condition, we will guarantee to be able to do the comparison at the end and return true when the 2 digits in the array are equal. Otherwise, we return false. Right, so now how do we implement our little helper function? Well, we can just iterate over all of the indices for I in range length of array and maybe -1, because we know we have to compute the overlapping, we have to compute the digit sums, but with overlapping sub arrays of overlapping sub arrays. And we just replace the array at index I. That is going to be the position as I, the value of position I, plus the value at position I plus 1. And what did it say? Module 10, right? Module 10. So that way we're going to replace the 39. The 3 would be replaced with the 2. The 9 would be replaced with the 9. The 0 would be replaced with another 2. And then at the very end, we have 1 left over that we can remove. And that's how we would do that at the very end. And I think that is everything we need. It's always good practice to go through the code with an example input that you have. So let's actually do this with 3902. So our array will be, in the first iteration, would be 3902, right? So we enter our while loop, we call the helper function, we now perform this update operation at position. Maybe I should write the indices here as well. So that we position 0, 1, 2, 3. So at 1, we would add the sum of position. At index 0, we would place the addition of 3 and 9 modulo 10. And that's going to be 1, right? No, sorry, it's 2. 9 plus 3 is 12. Modulo 10 is 2. Next, we're going to do the same with 9. So that's going to be 9. Then we're going to compute that sum. That's going to be 2. And we're going to remove the last element. Now the length of the array is 3, so we're not terminating yet. Instead, we're going to compute the next sum. So 9 plus 2 is 11, modulo 10 is 1. 9 plus 2 again, the same. And then we pop the last element out. So now we have length 2. So we're breaking out of the while loop. Both are the same, and we return true. So I'm kind of satisfied that this will work. And let's just run the test to see if I'm actually correct. Okay, both of the test cases passed, the positive one and the negative one. Great. Now it's time to submit it. and we're actually passing all of the